Good afternoon, everyone. Welcome back. Okay. Asha, Jannavi, Amit, Mohit, Chanchal, Parth, Mohammad, Tanvi, Vaidehi, Khushi, Ayush, Pavitra. Yes, Pavitra. I think you were not there last time. Huh? Okay. So last time we were talking about theoretical distributions, and we were supposed to do even Poisson last time, but I think the binomial took a lot of time. So we are now today going to do Poisson as well as the normal distribution. Okay. So let me just brush up what you have learned about the binomial, and from there we will go forward and go to the Poisson. Again, it has nothing to do with Poisson because there is a double S over here, and it is the name of a French person. Okay. So we are talking about theoretical distribution and the importance of them. What we told was, like, we have the frequency distribution. Just a minute. Similarly, we have the probability distribution. It also has the mean, median, mode, okay, and standard deviation. So variance, those features are also there. And then, like, we form a frequency distribution table. Similarly, we can make a probability distribution also, and where we can find the expected values, and then we compare the values that we obtain from the formula to the actual observed values. Okay, so it's a very interesting topic. It is very practically useful also. Okay, we may think of probability distribution, which is distributing like the total frequency. We are calling it as theoretical probability distribution because such a distribution exists only in theory. Okay. What are the 3 points that we have to remember is the frequency distribution gives us what? The number of times a data point occurs. Okay, like if we are discussing marks, so if there are 5 students who get 10 marks each, so we'll write frequency as 5. Okay, but what does the probability say? That probability gives us that the data point will occur. Whether or not we will have students with 10 marks is given by the probability distribution. Okay, second, it is used to predict short term. The third is statistical analysis is possible only on the basis of theoretical probability distribution. Setting confidence limit or testing statistical hypothesis about population parameters is based on the probability distribution of the population under consideration. So what we do, we have a population. Okay, population need not be only people. Okay, it may be about things, it may be about objects. Okay, so when I'm saying the word population, it means more than one. Okay, so you have a fairly large size of group. Okay, so that is referred to as population. Okay, and then we apply the confidence limit. Then we use the testing hypothesis, and we find out. Okay, so that is not. We don't have to go in so much of detail. You just need to know. And as I told you, you can define a mean, median, mode, and standard deviation in the same way as we have done for the binomial. Okay, as we have done for the frequency distribution, the same measures of central tendency. Okay, then we are talking about that we have probability distribution, then we have discrete, and we have continuous. So there are many. So in the discrete, we are talking about what? We are talking about binomial and Poisson. And here we are talking about the normal distribution. Okay. Then we talked about what are the application of binomial, where we use it where the trials are independent. Okay. And each trial leads to either a success or a failure. Okay. So we are using it for coin tossing, sampling, genetic experiments, and so on. Okay. Then we talked about Bernoulli's trial because binomial is based on the trials, and the trials we usually take as Bernoulli, which is IID, independently identically distributed, and outcomes are 0 and 1. Then we talked about features. Features are that it is mutually exclusive and exhaustive events. And then we have success or failure. Then the trials are independent. And then if P is the probability of success, then Q, which is equal to 1 minus P, is the probability of failure. Okay. And the number of trials is a finite positive integer. Okay, so N is positive. It is not only positive and it is also finite. Okay, Khushi, the other Khushi, Kuppas Gaudar, then Ayush, Ritu, Vansh, Pratyush, Gautam, Amar, Vaidehi, Tanvi, yes, Chanchal, the other Chanchal, Dhruv, Vidisha, Zo, Navya, Harshini, Bhumika, Samreen, Vidushi, Punit, Shivam, Shreya. Okay, Pavitra, you were there last time? Okay. Swati, Palak, Harshita, and Renu. Okay, yes. Then we said that when we are saying that x is following a binomial distribution, then we will write it as x follows the binomial distribution. And what is binomial? It is biparametric. What are the parameters? There are two parameters. What are they? N, the number of trials, and P is the probability of success. Okay. So this is how you have to remember. And then we will write fx as probability mass function is given as equal excuse me, ncx p raised to x q raised to n minus x, where x takes the value 0, 1, 2 up to n. Okay, so this n is also very important because we are saying the trials are finite. Okay, or it is equal to 0 otherwise. So other than these discrete values, if there is any other value for x, the value for the probability mass function will be 0. Okay. Then the important theory part we talked about, if that summation fx is equal to f1 plus f2 plus f3, and it will all total to 1. Binomial is known as biparametric. What are the parameters? N and P, and mean is given by n into P. Okay. Why we are revising this? Because Poisson is very similar to binomial, because binomial will tend to Poisson also. Okay. Depending on the values of two parameters, binomial distribution may be, okay, yes, then we are talking about the modes. Okay. What are the modes? If not integer, okay, if not integer, what? N plus 1 into P. If it is not integer, take the integer value. Take the integer part. If it is integer, then you have two. One is n plus 1 into P, and the other is n plus 1 into P minus 1. Okay. So those are the two modes. The variance is given by sigma square is equal to npq. We know that mean mu is given as n into p. Okay. And so mu is always greater than variance for a binomial distribution. Okay. So this is a very important statement that we have written, that, okay, additive property, if I have two independent variables, x which is also following the binomial and y which is also following the binomial, the same with the same p, then you can use the additive property that if I add these two data sets, I will get a new data set which is following the binomial distribution with probability P, and N will be equal to N1 plus N2. Okay. Okay, yes, we were here last time. So in this, you just need to know the theoretical part. That is, I have a theoretical distribution, okay, this binomial, and I have the actual observed values, and I will try to find out or try to predict the values and then compare it with the actual values, okay. So in order to fit a theoretical probability distribution to an observed frequency distribution, it is necessary to estimate the parameters of the probability distribution. So how do I use, which method do I use to find out the population parameter? One method is called as the method of moments, okay? Okay, so the question that can be asked, theory question, I've just written it down because that is the only thing. You won't get the huge sums because you can do the sums. Sums are very interesting, but for 1 or 2 marks, you cannot have those kind of sums because you have to first form the table for the predicted, and then you write down the observed, and then you find the difference and all this. This is not be there in the exam. The method usually applied for fitting a binomial distribution is given by the method of moments. Okay. Now let us come to the Poisson. Okay, so far so good. Everybody is good with it. Renu, good afternoon. Arpan, good afternoon. Rohit, yes. Question, the answer to your question. हाँ मोहिल कुमार, आप कैलकुलेटर लेके जा सकते हैं एग्जाम में, लेकिन सिंपल वाला लेके जा सकते हैं, साइंटिफिक नहीं लेके जा सकते. हाँ पीयूष, आप जहां तक हो सके जो भी फॉर्मूले आपको, जितने भी पीडीएफ अपलोडेड हैं उसमें से आप देखिए और उसमें से याद कर लीजिए, बिकॉज फॉर्मूले तो स्टैटिस्टिक्स में सबसे इम्पोर्टेंट है. फॉर्मूले के बिना तो स्टैटिस्टिक्स हो ही नहीं सकता. तो आपको और याद करने की जरूरत नहीं, आप बहुत बार प्रैक्टिस करोगे तो अपने आप से याद हो जाएगा. ठीक है. यस सलोनी, गुड आफ्टरनून. Yes, Asha, I have that question. We'll be asking. Yes, Samreen, method of moments. Varun, clear? Yes. Mohammed, I'll just look into that question that you're asking, okay? Yes, M. Gowda, good afternoon. Nancy, good afternoon. Vaidhi, what do you do after registration of exam? You check when the website to see when you can download the exam hall ticket, okay? अमृत, कोई बात नहीं, आप वो कुछ बुरे मार्क्स नहीं है, आप थोड़ा सा और पढ़ाई कर लीजिए, आपका हो जाएगा. ठीक है. बहुत बार ऐसा होता है कि आप पहली बार ये कर रहे हैं, एमसीक्यू अटेम्प्ट कर रहे हैं, नेगेटिव मार्किंग का अंदाजा नहीं आता और हम थोड़ा जोश में कर जाते हैं, तो आपको पता हो, मतलब थोड़ा सा अब आपको आइडिया आ गया है. आप उसमें से ये भी देखिए आपके करेक्ट कितने हैं और नेगेटिव मार्क्स कितने मिले हैं. ओके. तो for everyone, this is a because this is my last lecture with you, so I would like to give you a few tips also, telling you that it is very important that you pay attention, that you do not give away negative marks. Okay. Solve it properly, solve it with ease. You should not be very slow, you should not be very fast. And how do I do that? I can do that only by practicing with a timer. Okay. So even at home, just think of like you take 10 questions, try to solve them as fast as you can, see how many correct, how many incorrect, and mark yourself. Be very strict with yourself and mark it that okay, this is this. अरे ये मेरे को मालूम था. No, but you should give yourself negative marks, and you maintain in your notebook. Okay, today 29th of August, I got 5 out of 10. Next, I will go and this 5 out of 10 is correct so many, incorrect so many, plus marks, negative marks. Okay, all those things. You do it. You maintain that diary with you. Okay, and diary does not mean you have to go and buy simple diaries. Okay, you just have to take any rough pages. You can just staple them and make them your diary. Okay, no need to buy anything, and then do it. And as far as possible, all the formula you should write down every day. Okay, every day if you write down the formula, what will happen for the first on the first day, you may take even a 1 hour to write down all the formula. And as like if you start from now, so by the end of September, you will be writing all the formula in 15 minutes, because then you don't have to see the notebook. Everything you are knowing by heart. Okay, and formula are very important, otherwise, because without that, you can't do anything. Okay, so you must know what is the formula for mean. You must know what is the formula for mean deviation. Okay? Simple sums from there. When you go, then probability, then what is the formula for a combination, what is the formula for a permutation, time value of money, very important chapter. Okay, so all those things you will be needing. Okay, and anyone who has not got through in the last attempt does not mean that you're not good enough. It just means you need to practice more. Okay. Yeah. Yes, Pavan, good afternoon. Okay, so what is Poisson distribution? It is again theoretical. Also remember, it's a discrete. Okay. Poisson distribution is a theoretical discrete probability distribution. TDPD. Okay. Theoretical discrete probability distribution, which can be described and which can describe many processes. And so the Simon Poisson of France introduced this distribution in 1837. Okay, so it stood the test of time also. What does the Poisson model say about probability? It says that let us take take a random experiment. Okay, and then I take a very small time interval t to t plus dt. Okay, I just take the time interval from t to t plus dt. Okay, and this dt is very small. Okay. Then we say that the probability of finding success in the small interval, so the probability of success is equal to kt. What is this k? K is constant and greater than 0. Okay. So then the probability of having more than one success in this time interval is very low. So I am taking time interval in which I will have only one success. Okay. So one success. Okay. Then probability of having success in this time interval is independent of t as well as earlier successes. So that is, it is an independent. So what we obtained earlier, it is not going to affect us now. Time interval of t. Okay. So when we are taking this, we say the probability of success is given by e raised to minus kt raised to x upon x factorial. Remember x factorial? X factorial is nothing but 1 into 2 into 3 into so on up to x. Okay, up to x. Now, and what does my x take the value? X takes 0, 1, 2 up to, very important, up to infinity. Now what I do is, in this, instead of writing kt, I will write it as m. So I will get probability of success to be equal to, this is the formula we are going to use, e raised to minus m raised to x upon x factorial, x going from 0, 1 up to infinity. Okay. So this is the model which is known as the Poisson model. So this is the formula. This is only for your academic understanding. Or exams sums we are going to based on this. स्वाति, I don't know. You have to check when the admit cards. चले, आपका अभी और होना है ना ये correlation regression. Yeah. That's what I keep. Everybody, I'm telling you, give your mock test. Timing. Put a timer and solve. You may know a lot, but if you don't fit it into the time, you can't do anything about it. नहीं ध्रुव, मैं नहीं पढ़ाऊंगी, शायद सर पढ़ाएंगे आपको कोरिलेशन रिग्रेशन. Yes, Khushi, if you are not sure of the answer, don't mark it. Okay, you can just circle in the question paper that you want to come back to that question. But just make sure that you are leaving the place in the answer sheet, okay, properly. Just make sure you do that. You can get that printed also, that answer sheet, na, where you have to जाते हैं. Yes, Priyadarshini, you can use M, you can use lambda, okay? In some books, you will also see, like in your maybe school textbook, it is e raised to minus lambda raised to x upon x factorial, okay? So those who are very familiar with mathematics, there is no problem. We are used to lambda, gamma, beta, but those from the commerce, they may find it a little difficult. So for them, we use M. Vaishnavi, I think only 2 chapters now, correlation, regression, and index numbers are left. Thank you, Amrit. No, I think both the chapters are to be taught by sir. I don't know. I haven't got the message. Vaishnavi, those of you who are not able to, not only Vaishnavi, any person who is not able to solve logical reasoning question, please go back to my videos on the LR section. Not only this time, you can also see the ones I had done earlier, because sometimes, in like time wise, I may take more or less time depending on the students. Okay, so some more questions may be solved in the earlier batches also. So visit the batch 6, batch 7, okay, and there you will see the LR section. I have taken mostly for 2-3 years, I am taking the whole of LR section. So you could go and visit that. वैष्णवी, आप वो जेरोक्स वाले के पास वो लेके जाओ, उनको बोल दो ये वाला प्रिंट करके दे दे, तो वो आपको दे देंगे प्रिंट करके, और फिर उस पे घर पे प्रैक्टिस कर लेना, ठीक है? Okay, see, any questions you have, under the video in the YouTube, you can just post it wherever my sessions are there, the YouTube videos, you can just post the questions over there. You can send it to the institute, they will also solve it. But if you post it over there, within like 2-3 days, I will just go to those videos and I will just see if there are any questions posted, and I put in the answer below the YouTube video, okay? So make sure you don't get extra sheets. There's one sheet already attached to the question paper. And on that question, extra sheet, only that question and that paper is there for solving or for doing your work. Yes, Adab, I will also miss you all. Thank you, Dhruv. Okay, yes, Dhruv, happy Raksha Bandhan to you also and to all my students. Yeah. We also tie each other Raksha Bandhan, okay, Rakhi, the Rakhi of knowledge, of wisdom and success, okay? Okay, Palak, I will just see, I don't know. Mohil, you can see the videos, earlier videos. You could do that and there you could see this. So all the batch 7 videos you can see, okay? You can just start revising. You can go back to the first one and start doing. No problem, there is no problem if you, that is what the institute has done, so that you can join anytime maybe those are not live lectures, but it is as good as live, all the pace is slow, it's easy for you to understand. And if you know something, okay, you already know this concept of mine is clear, you can always forward that video and wait and see. Like, you can always solve those questions, and all the PDFs are already there on the website, okay, institute's website. So from LCC you can download the PDF. Even if though you've joined now, you can see all the PDFs over there. Okay, Mohin? Yes, Bidisha, you have to do the rough work everywhere around the questions. There's one page at the last, just write it small and solve it, okay? Nay, Samrin, you will get log tables, anti-log tables, everything you will get over there. You can't carry anything with you. Yes, Vaishnavi, there are two sheets, one at the starting and one at the end. So wherever you find the place, just quickly solve it. Yes, thank you, Mohammed. Aparajita, what question? Have you put any question? Yes, Priyadarshini, you have to use only black pen. Om, yes, happy Rakhi to you. Aparajita, you have to download the hall ticket from your login, okay, in the BOS. So, knowledge portal you have, from there you can, yes. Yes, Palak, thank you for your virtual Rakhis and sweets. Yes. Yes, Bidisha, I'll share my CA journey. Yeah. Yes, thank you. Read, good afternoon. Amit, thank you for liking the teaching. Okay. Yes, Vidisha, I'll talk about my CA journey at around 4 o'clock. Harshini, answers have to be put in color in the OMR sheet, okay? Nowhere else. You don't just put the tick mark on the question paper. It will be of no use. You have to color the answer, the OMR sheet. Okay? So, either of these two formula you can use. So, since e raised to minus m is equal to 1 upon e raised to m is greater than 0, when m is 0, it follows that fx is also greater than or equal to 0 for every x. Okay. And summation fx, that is f0 plus f1 and so on, plus fn is equal to 1. Now, Poisson distribution is uniparametric. Uniparametric because there is only one parameter. What is the parameter? Parameter for Poisson is m. Okay. What is m? M is the mean. The mean of the Poisson distribution is given by m. The variance is given by, so for a Poisson is equal to variance. Okay. Mean is equal to variance is equal to n. Like, and for mode, same condition, not integer. Take the integer part, and when it is an integer, okay, the largest integer contained in m, if m is not an integer, so is m, and m minus 1 is m is an integer. Okay. Now, if n the number of independent trials of a binomial, okay, this is very, very important. You may get a theory question on it also. Poisson approximation to binomial distribution. Okay. So what happens is, if my n is very large and my value of p is very small, then n into p, if it is finite, then then what happens, we are going to see. This we use it even while solving the problems also. Okay. If m, the number of independent trials of a binomial distribution, tends to infinity, that is, n tends to infinity, and p, the probability of success. So p, the probability of success tends to 0, and m, which is equal to n into p, remains finite. Okay, remains finite. Then the binomial distribution with parameters np can be approximated by a Poisson distribution with parameters np. So this is important. So then even though I have a binomial distribution, you know the binomial distribution is NCx, p raised to x, q raised to x will tend to the Poisson distribution is e raised to minus m raised to x upon x factorial. Okay. But this is a very important condition, remains finite. Like we had the additive property of binomial. Similarly, you have the additive property for Poisson. Poisson, it is easy because you have one parameter only. It is uniparametric. So what will happen? The addition will also be easy. Poisson distribution is applied when the total number of events is pretty large, but the probability of occurrence is very small. So this is an important condition where I will use Poisson distribution, where the n, the number of trials is very large, but the probability of success is very small. Then we use the Poisson. So for example, distribution of number of printing mistakes per page of a large book. Okay. Then distribution of number of accidents on a busy road per minute. Okay. Then distribution of number of radioactive elements per minute in a fusion process. Okay. Those who have done science would understand fusion process. Okay. The distribution of number of demands per minute for health center and so on. So these are just the examples. So the why we have written all this is so that if they ask you for this, what distribution should you use? So you should know whether you can use Poisson or whether you should use normal. Okay. But because these are discrete, okay, number of accident is discrete, you can count the number of accident. So you will use the discrete. If it is a continuous thing, you will use the normal distribution. Okay. So even fundamentally while reading also it becomes clear that you can eliminate normal distribution here. Now for example, the question is, which one is not a condition of Poisson model? Okay, so wherever these are negative, you have to be very careful. The probability of having success in a small interval, small time interval is constant. The probability of having success more than one in a small interval is very small. Okay. Yes, this is which condition? Let us see what are the conditions for Poisson. Okay, these are the three conditions. First is the probability of finding success in a very small time interval is KT, where K is a constant. KT is not constant, K is constant. Okay. So KT is constant. The probability of having more than one success in the time interval is very low. This is the second condition. Third condition is the probability of having success in this time interval is independent of T as well as earlier. Independent of T and earlier. Okay. So what is the first condition? Finding of success is in a very small time interval is given by KT, where K is constant. Then probability of having more than one success is very low. Then third is that it is independent of T and also earlier successes. So using these three, can I answer the question number 20? Let's see. The probability of having success more than one in a small time interval is very low, very small, correct. The probability of having success in a small interval is independent of time as well as earlier successes, yes. Condition number 3. The probability of having success in a small time interval t plus dt is kt for a positive constant. This is C1. The probability of having success more than one is very small. This is condition 2. So condition 1, condition 3, condition 2 for the Poisson model. So the probability of having success in a small time interval is constant is incorrect. Okay. Which of them is uniparametric? Binomial, you know it is n and p. Here this is m. For normal, you will have mu and sigma square. Hypergeometric is again a discrete type of this thing, and which is out of syllabus. So obviously that will not be the answer. So uniparametric. Okay, Poisson. Just write down the parameter also. Okay, so from there also you can get the answer. For a Poisson distribution, mean and standard deviations are equal. Mean and variance are equal. Standard deviation and variance are equal, both A and B. Yes. For 22nd, can anybody put in the answer? 22nd, 23rd, and 24th. I want to see your answers. Moil Kumar, world's best teacher. Thank you. Mostly January they will give you in the paper itself. Okay. Shreya, you can always practice more of LR from any of the competitive exams. You know, NDA entrance. You have banking, clerical exams. Everywhere you will have this. You know, you may have GRE, TOEFL, any entrance to BBA. College entrance exam also has MBA exams. Okay. 20, Om is saying 20, for 20 it is A. Okay. For 22, what is happening? 22, Varun is saying B. Varun, Bhumika, Priyadarshan, Swati, Vaidehi, Deepika, Dhruv, Swati, Ritu. Ritu, it is B. Okay, Om has got it correct. Okay, so for a Poisson distribution, mean and variance are equal. Okay. Then, remember we did that over here. Okay, here we have written. Okay. Mean is equal to, variance is equal to M. Okay. It's all there in your study material also, so don't worry. Nothing very difficult. You just follow it properly. Poisson model may be 23rd. How many of you answered? 23rd D. Yes, A or D. Okay, this is very important. This OR is very important for Poisson as well as binomial. Okay, Poisson distribution is always symmetric, always negatively skewed, symmetric only when m is equal to 2, always positively skewed. 24th. Okay, always positively skewed. For example, you remember last time we talked about binomial. Binomial will be symmetrical at what? At p is equal to half, right? That is possible. Other than that, this will be the case. For Poisson, it is always positively skewed. Then 25th and 26th. Sahana, 20th answer. A is the answer. Okay. Which is not a condition for Poisson. A. अच्छा. Dhruv Satya hai? World best teacher? Yes. Okay. So let us do the next one. 25th and 26th. A binomial distribution with parameters n and p can be approximated by a binomial Poisson distribution. This is a little tricky one, so that you have to read the words very carefully. Is this correct? This is incomplete. Okay, this is not incorrect, but it is incomplete. N tending to infinity, yes, that is a requirement. But it also has p tending to this. So this is also incomplete. N tends to infinity, p tends to 0. Again, it is incomplete. Why? Because NP remains finite is very important, and that is why between C and D, D is the correct answer. Okay. (26) For Poisson fitting to an observed frequency, observed frequency distribution, we equate the Poisson parameter to the mean of the frequency distribution. We equate the Poisson parameter to the median of the distribution. We equate the Poisson parameter to the mode. Okay. So what is the Poisson parameter M? You equate it to what? You equate it to X bar of the frequency range. So average of the frequency distribution X bar, you equate it to that. And so we to the mean of the frequency distribution. Okay. You don't need to go into detail, okay, because this chapter is very huge as such. But what they have done is that they have, this is only the introduction to theoretical distributions, okay. So you can go a lot deeper, but that's not required from the exam point of view. Yes, if you're very eager, you can always refer to other books on statistics and try to do them, okay. No problem with that. Number of misprints per page of a thick book. Because it is a thick book, what will happen? Number of pages will be large. Printing mistakes. Okay, normally an editor will check everything and do, and so the number of printing mistakes will be very small. Right? Isn't it? And now with all the grammar equipments that you have on online and all, you can always check and correct everything. So printing mistakes will be very small. So N is large, P is very small. So number of printing mistakes per page follows the Poisson distribution. Okay. Sana, 27th question. Okay. Okay. If the standard deviation of a Poisson variant X is 2, okay, so what is given to us? Sigma is equal to 2. Means what? Implies variance is equal to sigma square, which is equal to 2 square, which is equal to 4. For Poisson, mean is equal to variance, which is equal to 4. Okay. Now you have Px is lying between 1.5 to x to 2.9. Now this being a discrete, what will be the value for x? X will be equal to 2. Okay. Because between 1.5 and 2.9, only the number 2 is there. So I will have fx, which is equal to e raised to minus m into m raised to x upon x factorial to be equal to f of 2, which will be equal to e raised to minus, mean is 4, minus 4 into m is how much? 4 raised to 2 upon 2 factorial. Okay. Now this is f of 2 is equal to e raised to minus 4. The value is already given to me, which is equal to 0.01831 into 4 square is 16 upon 2 factorial is 2. So this is equal to how much? 2 ones are 2 eights are 8 eights are 64, carry over 6. So this is 0.144. Okay, so D will be the correct answer. Okay, have you followed what was given to me? The first step, standard deviation was given to me. I write that down. From there, I calculate the variance, and from variance, I calculate the mean. Then I put the mean into the formula and x, value of x, and I solve and I get this. Yes, very good. You got it correct. Okay. Everybody understood? Just put in the chat box whether or not you've understood. And for those who've understood, let us go to the next sum. Sahana, the value of e raised to m will be either given to you, okay, like I given you over here, or you will get the exponential tables, okay, like you have the log tables, you have the exponential tables, and from those you can find it. You have the appendix in your study material, there also you can see, okay, there you can see the exponential table. So all you have to do is find out for m value of m equal to -4, and there you will get, okay. Okay, Sahana, clear? Yes, crystal clear. Now let us do. If the mean of a Poisson variable x is 1, so m is given to you as 1. What is p? X is the value at least 1. Okay. So p x is greater than or equal to 1. Now, like we did in on the subject of probability also, whenever you have this, now x takes the value 1. So it can be 1, 2, 3, 4, up to, I don't know, infinity. So what I do, this is 1 minus p x less than 1. Okay. So minus p x less than 1. Now, what is the value of x less than 1, which is equal to 1 minus p of 0? Okay, that is the only value because x takes the value 0, 1, 2, 3, 4. Now, on the left hand side, I have x greater than or equal to 1. So, on the right, what will it be? It will be less than 1. What is less than 1? Only 0. Okay. Let me show you with the timeline also, in the number line also, sorry. This is my number line. This is my 0, 1, 2, 3, 4, and so on. Okay. Now what happens? Because there is nothing on the left hand side. Why? Because my x cannot take negative values. So my number line is starting from here. Now what do they want? X takes the value at least 1. X takes the value at least 1. So that means from here, it is wanting to go this side from 1. Means what? I know that total probability is always equal to 1. Now, if I want to find this, what will I do? This total is 1. So, from this 1, I subtract this portion. Okay, from this 1, I subtract this portion. Okay, and for that, what do I know? I just need to put the value of x as 0 because there's nothing below that, and from this point, everything is above. That is x raised to 1, x equal to 1 and more. Okay, so I have 1 minus p of 0. So what will that be? What is my formula? My fx is what? E raised to minus m raised to x upon x factorial. So this will be equal to 1 minus what is e raised to m is minus 1, m is minus 1. 1 raised to x is 0. Okay, x is 0, m is 1, x will be 0. Okay, upon 0 factorial. Now remember, 0 factorial is always equal to 1 and not 0. Okay, remember that. And 1 raised to 0 is always 1. Okay, so a raised to 0 is always equal to 1. So remember this. So what do I have? I have 1 minus e raised to minus 1. Okay, which is equal to 1 minus e raised to minus 1 is 0.3676. 3676. So how much will this be? 4, 2, 3, 6, 632. See, Okay, C will be the correct answer. Okay. Yes, very good. Om, Swati, Deepika, Khushi, Pratima. Yeah, very nice. Let us go to the 11th sum. If x follows the Poisson with parameter m and its coefficient of variation is 50, what is the probability that x would assume only non-zero values? Okay. Remember coefficient of variation, which is equal to sigma upon x bar into 100. Okay. That is why you must know all the formula for statistics. Okay. Very important. Yes, Harshita, Vidisha, correct. Okay. Let us go to the next sum. So you have sigma. Now, you know the coefficient of variation formula is sigma upon mean. Okay. That is standard deviation upon mean. Now what for Poisson, sigma square is equal to m, right? For Poisson, variance is equal to mean. We know that. So now instead of sigma, what can I write? So sigma is equal to root of m. Instead of sigma, I can write root of m. So what will happen is coefficient of variation is given to me as 50. 50 is equal to sigma. Sigma is what? Root m. What is x bar? That is mean. Mean is m. For a Poisson, mean is m into 100. Now what will I do? This is m. I can write it as root m upon root m into root m. Remember? In a subtopic of indices is equal to 50. So this 1 root m is going to cancel. What will I do? I will take the root m to this side and I will take the 50 to here. So I will have root m is equal to 100 upon 50. So 51s are 52s are. So I have root m is equal to 2. Squaring both sides, I have m to be equal to 4. Okay. Now I have got the value of m, and for a Poisson, I only need the value of m to be able to solve it. So let me put it in the formula. What is the formula? F of x is equal to e raised to minus m raised to x upon x factorial. Okay. So when I substitute here, which is what? What is the probability that x would assume only non-zero values? So what will I have for non-zero values? Okay. Means what? Non-zero values means what? X is greater than or equal to 1. X is not equal to 0 means x is greater than equal to 1. So I will have f x greater than equal to 1 to be equal to 1 minus p of 0. Okay. So this is equal to 1 minus e raised to 4 minus 4 m is 4 4 raised to 0 upon 4 factorial. Oh, 0 factorial. So how much is this? This is given to me as now 4 raised to, again very important, please don't miss out. 4 raised to 0 is also equal to 1. 0 factorial is also equal to 1. So I will have 1 minus e raised to minus 4, which is equal to 1 minus e raised to minus 4 is 0.01831. So how much will this be? 98, 982. 987 982. So B will be the answer. Okay. So here we are using both concepts, one from the measures of central tendency and one from the Poisson. So what is the measure of central tendency formula I am using is that coefficient of variation is sigma upon uh, x bar. What is sigma? Sigma is the standard deviation. What is x bar? X bar is the mean. Now also using the Poisson. Poisson says that mean is equal to variance. Okay, so that concept I have substituted over here and I have found the answer. Yes, okay. Just let me see the next question and then we'll take a break. Okay, don't worry. Okay, if 1.5% of items produced by manufacturing units are known to be defective, so what is the probability of defective is equal to 1.5%? Why is it? Okay, is equal to 1.5%, which is equal to 1.5 upon 100, which is equal to 0.015. Okay, so you can see the probability is very small, nearing zero. Now, produced by manufacturing unit as known to be defective, what is the probability that the sample of 200? Okay, you have to compare the 200 with 0.015. So, n is large, p is very small. Okay, so n, which is equal to 200, is large, p, which is equal to 0.015, is very small. So, binomial approximation to Poisson. Okay, so what will that mean? That means what is my m? M is equal to n into p because I have to ensure that this is finite only, then I can do that. N is how much? 200. Probability is 0.015. So 200 into 0.015 is 230, 1, 2, 3, 1, 2, 3. Okay, so m is 3. Okay. Since m is 3, now I have my formula fx is equal to e raised to minus m raised to x upon x factorial. Now what is no defective item? No defective means x is 0. So f of 0 will be equal to e raised to what is m? M is, let me write that down also so that you don't forget why we have taken 0. Since no defect is to be calculated, x is equal to 0. So p of 0 is equal to e raised to minus 3 into 3 raised to 0 upon 0 factorial. So 3 raised to 0 is 1. 0 factorial is also equal to 1. So this is equal to e raised to minus 3. And what is e raised to minus 3? What is the value? Do I have the value? 49. 0.049. 0.049, which is, what is the nearest value to this? This is A. Okay. Answer will be, I think, A. 12 some A. Yes. Okay. Understood till here? I think this is the one, Asha, you were talking about. We'll take this after the break. Okay. Yes. Cushy is mostly e raised to minus m, not this. They will just say that e raised to minus 3 is this much. That means you should get the value of m to be minus 3, okay? M to be 3, okay? Yes. 11th one? Yeah, okay. Right. Break, Lilith? Okay, so we are doing this. We'll do this 3, 4, then we'll switch to normal distribution and then come back for the remaining. Okay. So we have for the Poisson variate x p of x equal to 1 is equal to p of x is equal to 2. What is the mean of x? Okay. Now, if these are equal, what is my formula? Okay, what is my formula? Every time you're solving now, write down the formula, which says that P which is equal to e raised to minus m raised to x upon x factorial. Now here, what is the value of x? X is 1. Do I know the value of m? I don't know. Okay, so I will just substitute, which is equal to e raised to minus m raised to 1 because x is 1 upon 1 factorial, which is equal to e raised to minus m raised to 2 because x is 2 upon 2 factorial. Okay. Now, e raised to minus m and e raised to minus m will cancel. You are left with m is equal to m square upon 2 factorial is 2. So again 1m and this 1m will get cancelled. So m is equal to 2. Okay. So C will be the answer. Very simple. Okay. Yes. Next question. If 1% of the airline's flight, okay, so 1% probability is given, suffers from minor equipment failure. 1% probability means 1 upon 100, which is equal to 0.01, okay, is equal to P. Suppose a minor equipment failure in an aircraft, what is the probability that there will be exactly 2 such failures in the next 100 flights? So n is equal to 100. As you can see, n is large and p is small. Okay. So m, which is equal to n into p, which is equal to 100 into 0.01. So you will get m as 1. Okay, 100 into 0.01 will give you m as 1. Okay. Now you need to find out. So what are we doing? We are approximating the binomial and Poisson because n is large and p is very small. Okay. So now you want the probability of exactly 2 such failures. So what is x? X is 2. What is the formula? Okay. Every time I'm writing the formula, e raised to minus m raised to x upon x factorial, which is equal to, so x of p of 2 will be equal to e raised to minus 1 because m is equal to 1. 1 raised to 2, x is 2 upon 2 factorial. Now e raised to minus 1 upon 2. E raised to minus 1 is given to me here as 367879. 0.367879 upon 2. So answer will be equal to 0.1839184. Okay, so 14th will be the correct answer. Next question. If for a Poisson variable x, f of 2 is equal to 3 times f of 4. Okay. Now, f of x is equal to e raised to minus m raised to x upon x factorial. Okay. Using this, I have f of 2, that is e raised to minus m I don't know. What are they asking me to find out? Variance. You remember variance for Poisson, mean is equal to variance. Okay. So that is, if I find out the value of m, that will be equal to the variance. So e raised to minus m m raised to 2, okay, m square upon 2 factorial is equal to 3 e raised to minus m raised to 4 upon 4 factorial. Okay. Now, e raised to minus m will get cancelled. 2 will get cancelled. Here, this is 2 factorial and this is 4 factorial. 4 factorial is equal to how much? 24. Okay, so this is 2 ones are and 2 12s are. Okay, because 4 factorial, you remember 4 factorial is 4 into 3 into 2 into 1. Okay, so from there I got the 12 and 24. So what is left on the left hand side? Nothing. Only 1 is left. So 1 is equal to 3 upon 3 ones are 3 fours are. Okay. So not even 3. 1 upon 4. M square. Okay. 1 upon 4 m square. So that means m square is equal to 4. M is equal to square root of 4, which is equal to 2. M square, which is equal to 2. So A will be the correct answer. Okay. Now, X is a Poisson variate satisfying the following condition. What is the value of x less than or equal to 1? For x less than or equal to 1, that is I must have, what does this imply? I must have P0 plus P1. That is what they want you to find out. Now let us put it over here. The equation that is given to you, you have fx or px to be equal to e raised to minus m raised to x upon x factorial. So, okay, I am substituting for here. So this will be 9 into e raised to minus m raised to 4 upon 4 factorial plus 90 e raised to minus m raised to 6 upon 6 factorial is equal to e raised to minus m raised to square upon 2 factorial. Okay. Now, in both the sides, you can take, so eliminating e raised to m from both sides and dividing by m square upon 2, because 2 factorial is 2, we get, okay, so this here I am dividing by this, so m square will go away, so I will have 9 e raised to minus m, not m minus m, e raised to minus m also I have eliminated. So what am I left with? 9. I have 9 m square and you will have 3 4s are 12 plus, so this is 3 3s are 3 4s are, okay, and then I have 90 m raised to 4 upon, if I've eliminated, this is 3 4 5 6, so 720 upon 2, 720 upon 2 is 360, so 91s are 94s are is equal to e raised to, this is the answer here, you have 1. Okay, so I have what? I have got m raised to 4 3 m square plus m raised to 4 is equal to 4. So you have m raised to 4 plus 3m square minus 4 is equal to 0. let, remember you have the chapter on quadratic, let m square be equal to t. The equation becomes what? T square plus 3t minus 4 is equal to 0. Now this is minus 4, so you have, and this is plus 3, so 4 and minus 1. So m is equal to that is m square. T, which is equal to m square, is equal to minus, is equal to 4, or which is m square is equal to 1. Okay. So m minus this minus sign. You can't see the minus sign. Okay, just because the factors are 4 and 1. So this is minus 4m. So we cannot have the negative value. So we are taking m square is equal to 1. So m is equal to 1. Okay. Once I have that, I'm going to substitute over here for this. This is equal to e raised to minus m, e raised to 0, m raised to, so 1 raised to 0 upon 0 factorial plus e raised to minus 1, so not 0, e raised to minus 1. M is 1. So e raised to minus 1 into 1 raised to 0 upon 0 factorial plus e raised to minus 1, 1 raised to 1 upon 1 factorial. Okay. E raised to minus 1 is given to you as 36787. 0.36787, and everything else is 1, and here also everything is 1. Okay. So plus 0.36787. So how much is this? 36787 plus 36787. So 73 something. Yes. So C will be the answer. Okay. Yes, very good. Very good. So many of you are able to answer. Excellent. Yes. Okay, so now let us go to the normal distribution. Asha, your sum. See, Asha is saying P of, okay, this is not normal. This is about the earlier Poisson distribution. She is saying P of 2 is equal to P of 3, right? So, e raised to minus m square upon 2 factorial is equal to e raised to minus m cube upon 3 factorial. Okay, here remember you have to cancel this m, e raised to minus m, e raised to minus m will get cancelled. This m raised to 2 will get cancelled with here. So you will only be left with m. 2 and 3 factorial, so 2 will get cancelled. What will remain here is 3. So I will get 1 is equal to m upon 3. So m is equal to 3. And what are they asking? Standard deviation. Okay, so m is 3 means what? Mean, which is equal to variance. So standard deviation is what? Square root of variance, right? Which is equal to square root of 3. Okay, Asha? No, the question is same. Only they have asked you standard deviation instead of mean. Okay, so standard deviation we know is square root of variance, and we know mean is equal to variance. Deepika? राउंडिंग ऑफ होता है, उसको अप्रोक्सीमेशन नहीं, राउंडिंग ऑफ हो जाता है। तो आपको अराउंड जैसा आंसर में दिया होगा ना, उतने डेसिमल तक आप अपने आंसर दे जाइए और देखिए, क्योंकि इसमें देखिए आपको क्लियरली दिख रहा है 0.56, 0.67, 0.73, 0.8। तो आपको मालूम है आपका आंसर जो है 0.7 के रेंज में आ रहा है, ठीक है। तो आप डायरेक्ट भी कर सकते हैं। अच्छा, ओके। Amit, what question? This question? See, it is given that for a Poisson, M2, P2 is equal to P3. I will use the formula. What is the formula? E raised to minus m raised to x upon x factorial. What is my m? I don't know. What is my x? I know. Here it is 2, here it is 3. I substitute and then I eliminate. Okay. E raised to minus m will cancel with e raised to minus m because there is a equal to sign, that is possible. अगर यहाँ प्लस साइन होता है तो नहीं कैंसिल होता है, यहाँ इक्वल टू है इसलिए कट हो रहा है। ओके, एंड ई रेस टू m square and m cube. ओके, एंड दिस वे, इज इट ओके? So this is the revision of binomial and Poisson, which I will not take, and we start directly with the normal distribution. As you know that probability distribution, we are talking of two types. One is the discrete and the other is the continuous. For the discrete, we have studied with binomial and Poisson. For the for the continuous distribution, we are going to study normal distribution. Okay, and normal distribution curve looks like this. Okay, it is very near the x-axis, then it will go up, and very near the y-axis. Okay, it is going to tend like this, and here you will have the mean median mode. Okay, so this is a bell shape. These lines the lines of the normal curve will never touch the x-axis. Okay, there are 2 points of inflection. Okay, this is the point of inflection where from less you go to more, and this is the second point of inflection. Point of inflection 1, point of inflection 2. Okay, and the whole area under the curve, area under the curve represents the probability, and it should be totally equal to 1. Okay, so what is the normal distribution? It is biparametric. It is defined by what? It is defined by the mean and variance. Okay, a continuous random variable x is defined to follow a normal distributions with parameter mu and sigma square. So x follows the normal distribution mu and sigma square. Okay, what is the formula here? Okay, what you need to do is you need to simply use, this is the curve I have already drawn for you. We'll directly use the formula which we are going to use in while solving the sums. Okay, this is the shape I showed you, the probability distribution function. Then the curve is known as the probability curve. Now the figure shows that the normal curve is bell-shaped. Okay, bell-shaped. Okay, has one peak. Okay, and has one unique mode. One unique mode. Is that clear? The line drawn through x is equal to mu. That is, if I draw a line x from the x which is through the mean, then the curve will be symmetric about this line. Okay. Divide the normal curve into two parts which are equal in all respects. Such a curve is known as the symmetric curve, and the corresponding distribution is known as the symmetric distribution. So symmetric curve, symmetric distribution. Normal distribution is symmetrical about x equal to mu. Okay. It may also be noted that the normal distribution is symmetrical about p is equal to 0.5. So p is equal to 0.5, and also with mean, you will find that the normal distribution is symmetric. Also, these tend to both ends but do not meet. Okay, that is said to be a unique point, and the area under the curve, this whole area is equal to 1. And these are equal areas. So area from here to here will be same as area from here to here. Okay. The total area of the normal curve or for that any probability curve is to be taken as 1. So from minus infinity to 0, area under the curve is 0.5. From 0 to plus infinity, it is also equal to 0.5. Addition of these two gives you 1.0. Now, okay, I forgot the formula. So this is the formula. F of x is equal to 1 upon sigma square root of 2 pi. Okay, you know the value of pi, 3.14, which is also equal to 22 upon 7. So 1 upon sigma, that is the standard deviation, square root of 2 pi into e raised to minus x bar minus mu whole square upon 2 sigma square. Okay, x bar is the mean. Okay, and mu the whole square upon this. And this is very important. X goes from minus infinity to plus infinity, which is possible now in continuous distribution. Okay. Mu and sigma are constants. Now, using this formula, we are going to use it to find out the standard variate. Where did the formula go? Okay, now, yes. Now, this is a formula, and in this formula, if I put the values of x, x bar, and mu, and not x bar, sorry, mu and sigma, then what do we get? We will see that. Okay, here. Standard, normal, variate. I don't know how I did not put the name of the topic in on top. That's why I couldn't find it. Now what happens is, what is my fx? Okay, what is my fx? One upon sigma square root of 2 pi. This is not 6, it is sigma. Looking like a 6. Sigma 1 upon sigma into under root of 2 pi e raised to minus x bar minus mu the whole square upon 2 sigma square. Okay. Now in this formula, if I put mu to be equal to 0 and sigma to be equal to 1, so mu to be equal to 0 and sigma to be equal to 1, this will become what? 1 upon sigma is 1. So I will write down only square root of 2 pi e raised to here sigma square. So sigma is 1. So sigma square will also be 1 minus x bar minus 0 whole square upon 2. Okay, because you can't see this. This is equal to 2 sigma square. Okay. Very difficult to write down. 2 sigma square. Okay, now you can see. Now I have put sigma equal to 1. So what will happen here? I will have only 2. And this mu is 0. So I have this. Now what we do is, for this particular condition, when this is satisfied, we write the variable as z. Okay, we write it as z. So we will be using this. F of x is equal to 1 square root of 2 pi e raised to minus z square minus z, z square upon 2. Okay. Now what happens here is, therefore, this is known as parametric distribution. Okay, so this formula we'll be using the most. And more than the formula, this concept is very important for normal distribution. Okay. So we say that normal distribution is biparametric. What is it? Sigma and mu and sigma square. It is characterized by two parameters. Once the both parameters are known, normal distribution can be completely specified. What are the properties? Okay, let's see the properties. Pi is equal to 22 upon 7. E raised to minus theta is equal to 1 upon e raised to theta, whatever theta may be, and it will always be a positive value. Okay, e raised to minus theta will always be a positive value. And we can say that because it's a continuous, we are using the integration sign. Okay, for a discrete, we wrote down f0 plus f1 plus f2. Okay, you can calculate individually, but here you have to calculate it over a time interval. Okay, over a class interval. So what do I have? I have the integral from minus infinity to plus infinity as the basic formula. The mean of a normal distribution is given by mu. Since the distribution is symmetrical, it follows mean, median, mode of a normal distribution are always equal to mu. Okay. This sentence is extremely important. The standard deviation of a normal distribution is given by sigma, mean deviation of normal distribution. Okay. So this formula is very important again. Mean deviation of normal distribution is sigma into square root of 2 upon pi. Okay, now if I calculate 2 upon pi and then find the square root, it is equal to 0.8. So mean deviation about the median or mean, whatever you can take, is equal to 0.8 sigma. Okay, 0.8 sigma. The first and third quartiles are given by. Okay, this all are very important because you can score the marks so well because you don't have to think anything. You just need to know. You just have to tick mark those. Or even when there is a calculation, it will be a very small one. Okay, so I have Q1 to be equal to mu minus 0.675 into sigma, and Q3, that is quartile division 1 and quartile division 3 is equal to mu plus 0.675 sigma. I hope everybody is following. Yes, Asha, clear? Where did you get 2 factorial, Mohammed? Okay, so mean deviation about the mean or median is equal to 0.8 times sigma. Then quartile deviation 1 is given by mu minus 0.675 into sigma, and quartile deviation 3 is given by mu plus 0.675 sigma. Okay, when you have mu to be equal to 0 and sigma to be equal to 1, then in that case, for standard normal variate, you will have Q1 is equal to minus 0.675 and Q3 will be equal to 0.675 with a positive. That is for SNV because there I have mu to be 0 and sigma to be equal to 1. The normal distribution is symmetrical about x is equal to mu. Okay. So the normal curve is neither inclined towards the right nor inclined towards the left. Okay. So the normal curve y is equal to fx has 2 points of inflection. Okay, I was telling you about that. So x is equal to mu minus sigma and x is also equal to mu plus sigma. Okay. So whenever we say X is following a normal distribution, it is written as mu and sigma square. So here we are talking about variance and not the standard deviation. You can always find the standard deviation by taking the square root. Okay, this is the most important this thing, curve, where you can even see the area under the curve is given. So here, what is happening is, so from here up till here, okay, going anywhere forward, this is all equal to 0.5. Similarly, from here in this direction, it is again 0.5. Okay, so 0 point plus 0.5 is 1. Okay, and you can see these values. So I suggest that you keep this ready in your notebook, because some questions you can get directly from here. Okay, so what this means is that sigma, mu minus sigma, that is if I go one standard deviation. So up to from here to here, that is I am going from minus sigma to plus sigma. What is happening? This is giving you 34 plus 34, around 68% of the area. Then from here to here, it becomes around 95% of area. Zero point 95% of the area, and mu minus 3 sigma is equal to 99%. Okay, is that clear? Akib, yes, thank you, ma'am, for all the effort you put. I'm very grateful to you. Thanks a lot, Akib. Yes, Asha is following, Salon is following. Yes, mu and sigma, correct. Okay, so Bhiksha, what does skewness means? Skewness means what tilt there is. Okay, what is the tilt? So if I have this, if my diagram is like this, it means it is, the tail is moving towards the right and it is positively skewed. If it is like this, okay, and what is this? This is a symmetrical. Normal distribution is symmetrical. Okay, and what is bias? Bias means where the center of gravity is changed, or we may prefer one thing over the other. Is that clear, Viksha? वैष्णवी 0.95 और 95% में कोई फर्क नहीं होता डिस्ट्रीब्यूशंस में, ठीक है? आप उसको 95% एरिया अंडर द कर्व बोलो या 9.95 एरिया अंडर द कर्व बोलो, क्योंकि 95% भी क्या होता है, 95/100, वो भी 0.95 ही होता है ना, 0.95. तो इसलिए उसमें कुछ आपको टेंशन लेने की जरूरत नहीं है. आप डेसिमल में लिखो या परसेंटेज में लिखो, आंसर वही आने वाला है, ठीक है? सो यहाँ जो है, this 68 means what? This means mu minus sigma to mu plus sigma. What does this mean? This means mu minus 2 sigma to mu plus 2 sigma. And what does this mean? This means mu plus 3 sigma to mu minus 3 sigma to mu plus 3 sigma. Means what? Most of the area is going to be covered by 3 times the standard deviation. If you go to 3 times the standard deviation on both sides, it is going to cover 99% of your area. So very minute amount of area will remain outside this the bell shape that you have. Okay. Okay. So here I have written. You can have it like this. This you can see even in the PDF that I have uploaded. mu minus sigma x to mu plus sigma is 0.6828. And when I'm talking of standard normal variate, so I will write, instead of all this, I will write -1 is less than or equal to z is less than not less than or equal to less than z, which is less than +1. Okay, so same thing over here. We note that 99.73% of the values of the normal variable lies between mu minus 3 sigma to mu plus 3 sigma. Okay, and what lies outside is only this much, 0.0027. माने 0.27% सिर्फ आपके उतने कर्व के बाहर रहता है. Okay, if x and y independent normal variables with mean and standard deviation as mu1 and mu2 and sigma 1 and sigma 2. Okay, this is also a very important theory question also. Okay, so they will ask you, like for right from binomial, what we did, if I had n1 p and I had n2 p, then I could write it as n1 plus n2 comma p. Okay, when we had two different distribution and we are bringing them together. And for Poisson you had, okay, same thing. Okay, you had m1 and then you had m2 and then you could have m1 plus m2. But here what is happening is, when I have like this mu1 and mu2, so for one I have, suppose for one normal distribution I have mu1 and sigma 1 square, and for other I have mu2 and sigma 2 square. Then in that case what will happen is, when I want to find out x plus y, so for x plus y what we will have is n of mu1 plus mu2, and then you will have sigma 1 square plus sigma 2 square. Okay, so it becomes, you have to add both of them. Okay, so for mu1 plus mu2, that is the mean and as well as the variance. So where do I use the normal distributions? Okay, many social sciences, management, commerce find many applications. When n the number of trials of a binomial distribution is large and p the probability of success is moderate, neither too large nor too small, then the binomial also tends to the normal distribution. Poisson distribution also for large values of m approaches normal distribution. Okay, so if something like this is there, so x is lying between a and b, then you will find mu of b minus, so this will be phi of b minus mu upon sigma minus phi, that is a set of a minus mu upon sigma. Okay, so remember that you have to, that is b minus a, because this is bigger, this is smaller, so you will do b minus a. Okay, now let us see the questions. The most important continuous probability distribution is, because the word continuous is given, it is normal distribution. The probability distribution function of a normal variate is given by. Okay, so this is also a in a way very easy question. Okay, but it is easy only when you know the formula. So what is the formula? 1 upon sigma, probability mass function will be 1 upon sigma square root of 2 pi e raised to minus x bar minus mu whole square upon 2 sigma square. Now what is happening over here? Fx 1 upon this is 1 upon 2 x minus mu. This is not x. It is x minus mu upon sigma the whole square. Then what is b? So this is matching. So I think A will be the correct answer. What is happening in B? Minus x minus upon Oh yes, here this is incorrect because this formula is correct, but problem is here minus infinity to plus infinity. Okay, and see what is happening. See here, see in the denominator, sigma is gone inside the square root sign, which is not correct. Okay, so this is not correct, this is not correct. So A is the correct answer. 29. The total area under the total of the area under the normal curve is 1. Okay, total area is equal to 1. Then the normal curve is bell shaped. Okay, because this is how it looks like. Okay, and it's not going to meet. Okay, it is not going to meet. Okay, the normal curve is symmetrical. Okay, then area under the normal curve between minus infinity to mu is 0.5. Between minus infinity to infinity is 0.5. No, minus infinity to infinity it is equal to 1. This is correct. Between mu to plus infinity is 0.5. This is also correct. So both A and B. Okay, this is very important word. A and B is correct. Okay, because this is my x is equal to mu. Okay, I have the curve like this. So up to here, this area will be 0.5, and from here onwards it will be 0.5. So 0.5 plus 0.5 is 1. So both A and B are correct. So D is the correct answer. So this line x is equal to mu divides the curve into two equal parts. That can also be a theory question. So line will divide mu into two equal parts. The cumulative distribution function of a random variable x is given by, okay, f of x x is less than or equal to x is less than or equal to x, fx is greater. Greater is not a question, equal also not. Now a and b, what is the difference? The x should be small, okay, so we are using a. 34. The mean and mode of a normal distribution are always equal. The mean deviation about median of a standard normal variate. Okay, standard normal variate mean distribution is given by 0.8 sigma. This is the normal. For standard variable, sigma is equal to 1. For standard normal variable, sigma is equal to 1. So mean deviation will be equal to 0.80. So D will be the correct answer. If they ask you normal, then for the usual one, then it will be 0.80 into sigma. Because they're asking it for the standard normal variable, it will be into 1. Okay, because sigma will be 1. So this will be the answer. Quartile deviation of a normal distribution with mean of 10 and standard deviation of 4. Mean of 10 and standard deviation of 4. Quartile deviation is equal to 0.075 into sigma. Okay. So standard deviation is 4. So this is equal to 0.675 into 4. So how much is this? 24, 25, 26, 27. 0.2.7. Okay. So if you know the formula, you can easily do this. 37. For a standard normal distribution, the point of inflection are, okay, very important question. Point of inflection are sigma mu minus sigma and mu plus sigma. The symbol sigma is equal to sigma A indicates the area of the standard normal curve between 0 to A to minus A to sigma infinity minus infinity to A, and so you know it is between minus infinity to plus infinity. Okay, and if we are talking of the standard normal sorry. Okay, yeah, this is where I wanted to mark this also. See, for a normal distribution, what is the formula for the point of inflection? This is the formula for mu minus sigma and mu plus sigma. Okay. Now here what is important is they are talking of standard normal distribution. So for standard normal distribution, mu is equal to 0 and sigma is equal to 1 for standard normal distribution. So for a standard normal distribution, point of inflection, if here I put mu minus sigma is 0 minus 1 and 0 plus 1. This is equal to 0 minus 1 is minus 1 and 0 plus 1 is plus 1. So answer will be C. Okay. Please remember this because the word is standard normal deviation distribution. Okay, the interval mu minus 3 sigma, mu plus 3 sigma is 13. Okay. Here, all but 0.27% of the area of the normal curve, this is also true. Also true, but this is the correct answer. C will be the correct answer. If x and y are two independent normal random variables, then the distribution x plus y will also be a normal distribution. If x and y are independent normal variables with mean and standard deviation as mu1, mu2, then the following will be this. This will be the case. Okay, this is also important. Okay, this upon 2 sigma square upon sigma square root of 2 pi. Okay. Now in this, you have to compare this with this. Okay, you have to compare this with this. Now what is happening here? Fx of e raised to minus x minus 4 whole square upon square root of pi. Okay. Now what is the here? You should have something, but upon this is only 1. Here, what is the formula? E raised to minus. Why we are comparing that? Because once my exponential match, it becomes very easy for the numbers to match. What I need to match is my exponential. So what is this? What does this imply? 1 is equal to 2 sigma square. Because x minus 4 whole square, x bar minus mu whole square, that is there. But the denominator is having a problem. So sigma square, which is equal to variance, is equal to 1 upon 2. So what is sigma, which is equal to standard deviation, is equal to 1 upon square root of 2. Okay. So once I have that, what will be my, so if they ask you, you can find out the standard deviation like this. Now let us find out m. Okay. Now I know that x bar minus mu whole square here is equal to x minus 4 whole square. Okay. So this implies that mu is equal to 4. Okay. So mu is equal to 4. Okay. This is the last sum we are taking for the day. If two quartiles of normal distributions are 47, so Q1 quartile deviation 1 is equal to 47.30 and quartile deviation 3 is equal to 52.70. Why don't we write QD 2? Because quartile deviation 2 is the same as the median. Okay. So what is the formula for Q1? I know it is equal to mu minus 0.675 sigma. And what is the formula for Q3? It is equal to mu plus 0.675 sigma. Now this is given to me 47.30 is equal to mu minus 0.675 sigma, and this is 52.70 is equal to mu minus 0.675 sigma. Okay, adding the two equations, this is a simultaneous equation. Solve the simultaneous equations. So what do? I subtract. Okay, I subtract. So what do I get? 52.7 minus 47 point. This is equal to how much? 2 point. Okay, let us add. Let me add this. Okay, solve the simultaneous equation by adding the two equations. Why we are adding? Is because we don't want this decimals. Okay, so 47.3 plus 52.7, and this is 7179, this is 100. Okay, so 100 is equal to, so this will get cancelled, is equal to 2 mu. Now you know why I added instead of subtracting. Okay, so mu is equal to 100 upon 2, which is equal to 50. Isn't it great? Now we have found out the mean to be equal to 50. Okay. Now what is sigma? I will put it in any one. So 47.30 is equal to 50 minus 0.675 sigma. So this is equal to 675 sigma is equal to 50 minus 47.3, which is equal to 2.70. So sigma is equal to 2.70 upon 0.675. How much is this? This is equal to 4. So I have mean is equal to 50 and I have sigma is equal to 4. What is the mean deviation formula? This is equal to 0.8 times sigma. So 0.8 times 4, which is equal to 3.2. Okay. Has everybody got the answer? Q3 9F set. भूमिका प्लीज वेटेज के लिए आप ना वो दिया रहेगा इंस्टीट्यूट के, इसमें वो देख लीजिएगा. हाँ, टाइम नहीं मिला चंचल, मैंने नोट किया है. मैं क्या करती हूँ चंचल, आपका जो क्वेश्चन है ना, मैं आज का जो वीडियो है ना यूट्यूब पे, उसके नीचे आपको उसका सोल्यूशन डाल देती हूँ. ठीक है, तो आप लोग वहां से देख लेना. फॉर 28 इट इज ए. स्वाति, विच क्वेश्चन? हाँ, आप लोग क्या करना, वीडियो जो है आज का, उसके नीचे आपको जितने भी चैप्टर्स मैंने पढ़ाए हैं उसके रिलेटेड कोई भी क्वेश्चन होंगे, आप उधर डाल दीजिए, और उसको मैं वहां पे सॉल्व करके 2-3 दिनों में आपको उसका आंसर दे दूंगी. ठीक है, क्योंकि टाइम नहीं बचता है ना फिर. 28, yes, 28A is the answer. What is point of inflection, Chanchal? It means from where you are going from concave to convex or convex to concave. The curve, can you see? You'll appreciate that the curve is like this. So here, concave, and then it becomes convex. If you remember the chapter of lenses, those who have studied in CBSE, ICSE, and I think nowadays everybody, the syllabus is same for science and math. So in the chapter of lenses, you talked about the convex and concave. जहाँ पे कर्व के डायरेक्शन जो है अंदर की ओर से बाहर की ओर जाती है, तो उस समय वो जो है उसको पॉइंट ऑफ इन्फ्लेक्शन बोलते हैं. Yes, Indrajit also is talking about my CA journey. Are they into 35? What is saying? Okay, see, that is the problem because normal for the standard normal variate, you will have 0.8. But then, see, because sigma is 1, otherwise this is the correct answer, C or D. 39 का D क्यों रिजेक्ट किया? जो स्टैंडर्ड वे ऑफ बात करना है ना, एरिया अंडर द कर्व, द स्टैंडर्ड वे इज 99% of the area, okay? But then, see, they will not give you so near answers because this is 99% point something. So if you go for the mathematical accuracy, then it will be D. But uh, like when we are talking about in terms of how do we talk about it, we say for a normal distribution, 99% of the area will fall between mu minus 3 sigma to mu plus 3 sigma. Okay. Vaishnavi, you can send the email to the institute. Okay, you can do that. हाँ, मैं 10th में किया था. Okay. As far as my CA journey is considered, okay, just 2 minutes and then we'll wrap up for the batch. What has happened was that I did my MSc in physics, okay, and then I wanted to do something in finance, so I switched to trying to do CA. So I joined because I was graduate, so I could that time we could directly join the inter. So I joined my inter, and then after that, after I was giving my inter, then because I had come from the science background, so it was like very difficult for me to study all the commerce things. For accounts, I didn't even know what are the three rules, what is a real account, what is a nominal account, and I was feeling very down that, oh, I can't solve this. But then I said, like, once when we pass our 10th standard, in the 11th standard, all the students, and nobody knows about commerce, they learn, right? They learn. So I said, if a 16-year-old can do it, I will also be able to do it. So then I took the 11th standard, 12th standard books for accounts and I studied that because law was okay, income tax was okay, but I had difficulty with understanding how accounts are written, what are the laws. And so I took that, and then after that, after my inter, I had my son, and then after that, I completed my CA, and I teach at the institute, I teach at the colleges, and that is my passion. Teaching is my passion, and I have my own practice. And I practice in the field of RERA, that is the real estate law, which has come in for the whole of India. So I'm practicing in that area. So it was tough, yes, very tough. But being from the science background and now full-fledged commerce student, so I know what difficulties students have in mathematics. So I make sure that I take you along the journey where that fear goes away from your head and you are able to do it. So many of my students, when they start attending this sessions of maths and statistics, maybe it's with me or maybe it's with the other teachers also, that they feel that all the fear has gone away and they're very happy about it. And so always remember, our best wishes are with you. Embark on the journey of CA. It's a professional degree. It is going to be very tough. You may be very intelligent, okay? In school and colleges, you may have come first, but here maybe you're taking more than one attempt. Doesn't matter. You should not leave. You should do it until if you have enough passion and if you're ready to work hard. Because if you feel that foundation is tough, wait till you reach the finals. That is much tougher. So you should be ready to put in the hard work, okay? You will get the results, no doubt about it. But make sure you're concentrating on the concept, understanding the concept, giving some time to the concept to sink into. एक दिन में नहीं आने वाला है, so it's okay. You need to practice. And maths is a scoring subject, okay? Maths and stats. So you should try to get as many marks as possible. So once you do that, and also when you're going in for jobs, companies prefer students, CS students who have done their foundation and come. So because they know that right from the age of 16, 17, you have concentrated your effort on studying for CS. So your concepts are very clear. Your maths is also good. No, you're doing so many 16, 17 chapters of maths and stats and logical reasoning. So that means you're a very powerful person, knowledgeable person. So please continue your effort, and I'm always there with you. Okay. Okay. Yes. Yes. See, symbol names are what? Symbol names are, this is your mean. Sigma is your standard deviation. Sigma square is your variance. There is no other symbol, right? Yeah. Okay. Thank you all for your patient hearing. Have a great life ahead, and all the very, very best for your December attempt. Okay. Have a great day. And a very, very happy Raksha Bandhan to all of you. And when you pass, so when I'll be teaching the next batch, so you can like put in the message, or you can join one session and tell me that you have cleared your exam. Okay, I'll be very happy to hear from you all, and I'm confident that this batch is going to do wonders. Thank you all. Okay, Ashok ji.